Greetings, I'm John Gabriel and this is the New Calculus channel. And in today's video I'm going to show you a definite demonstration that there is no tangent line at a point of inflection. In fact, the mean value theorem doesn't even care about the point of inflection. So let me show you how it works, and you can decide for yourself if your mainstream calculus interprets a tangent line definition correctly or not. In fact, your mainstream calculus has never understood what is a tangent line. So I'm going to show you very quickly that there is no tangent line at a point of inflection, and it doesn't matter if there is a derivative there or not, because the mean value theorem still works, which means the fundamental theorem of calculus also works. So let's begin. Now, if we look at this example here, this blue curve, this blue broken curve, is this function called f prime of x. Its primitive is the solid red curve, and its derivative is the broken green curve. And you'll see that if we apply the mean value theorem to find the area under the blue curve, we'll see that it's 2, right? And the mean value at x equals to 3 is 2. The arithmetic mean there is 2, and 2 times 2 is going to give us an area of 4. Yes, because that's what a definite integral is. It's just the product of the arithmetic mean multiplied by the interval width, which is also an arithmetic mean, as I've explained in many other videos. Really, an integral is just a product of arithmetic means. So, and we see that if we try to find the area under the green curve, we in fact also get an arithmetic mean of 1, but we get it in 2 different places, and it doesn't actually apply to this interval of 4, 2 directly. It first applies to the intervals 2, 3 and 3, 4, and then just adds a 2 up and takes the average or the arithmetic mean again, and which actually ends up being 1. So you can try this out by using this function and creating these graphs and then finding the areas, and I'll show the areas as I'm showing you over here. Okay, so now the arithmetic mean doesn't actually care about whether there's a derivative there or not. Now in this case there is supposedly in the mainstream calculus a derivative there. In reality there isn't, because there is no tangent line there, because a tangent line never crosses a curve. So let's see now another example. So now in this example here, what I've got is this function here, the blue curve, yes, and it's actually undefined at 8. Okay, so but that doesn't actually stop us from using the mean value theorem, and when we use it we find that the area under the blue curve happens to be 4. Okay, by the way, this graph, as you can see, is not the same as that one. They're very different graphs. It doesn't matter. But at any rate, the arithmetic mean is actually located at x equals to 8. Okay, and 9 minus 7 is 2, and 2 times 2 is 4. So at x equals to 8, there is an inflection point on this graph here, but there is a vertical line that passes through it, or in your bogus mainstream calculus you call it a vertical tangent. It's not a tangent, and the mean value theorem, in spite of the fact that there is no derivative there, whereas there is a derivative here, it still computes the right value, because the mean value theorem does not care about points of inflection. Did you get that, you morons? Okay, so, well, for once and for all, this video and this demonstration that I've given you here proves to you that you cannot have a tangent line at a point of inflection. There is no derivative at a point of inflection. And the mean value theorem from which the fundamental theorem of calculus is derived in one step doesn't care about the point of inflection having a derivative or not having a derivative. Did you get that? And in actual fact, it doesn't have a derivative at a point of inflection. That is why it works, okay? It doesn't care about the points of inflection. It will still produce the correct value, provided the blue dotted graphs are smooth. In other words, they're continuous and they have a tangent at every point except the points of inflection, okay? So I hope that this demonstration here has given you a lot of food for thought. The best thing for you to do is to actually download this applet, which I'll provide in the details section, a link in the details section, and you can see what all the graphs look like here in the algebra section. You can see everything else here, how they're defined, and try different experiments with it. But so for once and for all, I've shown you now that it's not possible to have a tangent line at a point of inflection, because the mean value theorem has to be true, and so does the fundamental theorem of calculus. So either you have a derivative at a point of inflection and calculus is wrong, or calculus is right and you are wrong. I'll bet on the latter, okay? Well, this is the New Calculus channel. My name is John Gabriel, and until next time, goodbye.